Assalamualaikum and hi, my name is Norshifa Hazika. So today, I will going to discuss Newton's law of cooling or warming. In our daily life, we often notice that the temperature of an object changes depending on the surrounding environment. For example, if you leave a hot cup of coffee in a cold room, it gradually cools down. On the other hand, if a cold drink is left outside the refrigerator on a warm day, it slowly warms up. These changes don't happen instantly. They follow a certain pattern over time. To understand and predict this behavior, scientists use Newton's law of cooling or warming. This law helps us calculate how fast an object's temperature approaches the temperature of its surrounding. Now, let's look at the definition of Newton's law of cooling. This law states that the rate of change of temperature of an object is proportional to the difference between the temperature of the object and the surrounding temperature. In similar words, the greater the difference between the object's temperature and the environment, the faster it will heat up or cool down. Importantly, this law works for both cooling and warming processes. Mathematically, we can represent it using a differential equation. Based on this slide, I've already shown the meaning of every term from the equation, which is T bracket, show temperature of the object time T. Tm is temperature of surrounding object. dt over dt is the rate of change of the temperature. T minus Tm show a difference between temperature of the object time T and temperature of surrounding object. And lastly, K is a constant of probability.
For this problem statement, we consider a real-life situation involving Ahmad. At 4 o'clock in the afternoon, Ahmad finished his class and decided to buy a canned iced lemon tea from a vending machine on the way back to his room. After arriving at his room, Ahmad placed the canned drink on his study table in a room with a constant surrounding temperature of 26 degrees Celsius. At the beginning, the temperature of the drink is 7 degrees Celsius. As time passed, the drink absorbed heat from the surrounding air and its temperature gradually increased. After 12 minutes, the temperature of the drink rose from the 7 degrees Celsius to 11 degrees Celsius. This situation follows Newton's law of cooling or warming, which explains how the temperature of an object changes over time based on the difference between its temperature and the surrounding temperature. Using this model, we aim to determine the time required for the drink to reach 20 degrees Celsius and also to determine the temperature of the drink after 40 minutes.
Hi, so in this slide, I will tell you guys how to solve the equation A. So, the rate of change of the temperature is equal to K multiplied with the difference between object temperature and its surrounding temperature. So, when the time is 0 minutes, the temperature is 7 Celsius. And when the time is 12 minutes, then the temperature is 11 Celsius. So, the derivative of temperature towards to time equal to K multiplied by T minus 26. Then, we change the place of dt over t minus 26 equal to k multiplied dt. Then we integrate both sides. Then we get ln modulus t minus 26 equal to kt plus c. T minus 26 equal to exponent power of kt plus c. Then we separate with the multiple the kt plus c and get t minus 26 equal to exponent power kt multiplied exponent power of c. Then, we get equation is a exponent power of kt plus 26. Next, when the time is 0 minutes, we get 7 Celsius. So, we substitute 0 into the equation of a exponent kt plus 26 equal to 7. We get a equal to negative 19. Then, the temperature when the time t is equal to negative 19 exponent power of kt plus 26. When the time is 12 minutes and 11 Celsius, we use the previous equation and substitute the 12 minutes into the variable t. So we get negative 19 exponent power of 12k equal to negative 15 after 11 minus with the 26. Then we get exponent 12k equal to 15 per 19. To make k as a subject, we have to learn both sides. Then we get k equal to negative 0.0197. Therefore, the equation is negative 19 exponent power of negative 0.0197 t plus 26. So in this slide, I will tell you guys how to solve the question B. For the question B, we just substitute t equal to 40 into the temperature of t time equation, which is negative 19 exponent power of negative 0.0197 multiply 40 plus 26. And the result is 70.36. Therefore, after 50 minutes, the temperature of the drink is estimated to be 17 Celsius.
Newton's law of cooling and warming help us understand how temperature changes over time based on the surrounding environment. By using differential equation, we can predict future temperatures, estimate cooling or warming time, solve real-life thermal problems accurately. This law shows how mathematics is not only theoretical but also very useful in daily life. Understanding Newton's law of cooling and warming strengthens our ability to apply mathematics to real-world situations, and it can make learning more meaningful and practical.